Good morning, and thanks for joining us for today's webinar titled Steady Rests, When You Need One and What to Look For. My name is Ed Peter. I am the National Product Manager for the Steady Rest and Work Holding Division at LNS. With me in the background, we have our Vice President of Sales, Brad Hasty. He is going to be monitoring the questions and answer box that you'll see in the upper right-hand corner of your screen. And as I'm going through my presentation, if you have any questions or anything you would like to perhaps comment on, go ahead and enter those into that box, and Brad will try to respond as we're going along. If at the end of my presentation I have a little extra time, we may try to go to a live questions and answer session. So let's go ahead and get started. So a steady rest is a work holding device consisting of 3 rollers that close in order to engage and clamp a round diameter of the workpiece to provide support. When is a steady rest required? When the inherent strength of a workpiece is not sufficient to resist the force of a cutting tool, usually to support long rods or shafts. Also, to support the end of a workpiece without a tailstock engaged, usually to allow for second op machining to be completed on the end of the workpiece. These operations may include facing, drilling, boring, possibly adding a bolt hole pattern on the end of the workpiece. Here's just some typical common parts that might require a steady rest. Notice a lot of shafts, axle shafts, camshafts, crankshafts, gun barrels, going down the list all the way down to the last item, parts requiring secondary operations. Here's a part that might require a secondary operation. If you'll notice in looking at it, the part itself is pretty robust, probably does not need a steady rest to do any of the OD turning, assuming that a tailstock was engaged. However, if we disengage the tailstock to do any of the end work on there, you can see that the steady rest would be needed in order to go in and perhaps cut the ID chamfer, maybe to do some ID boring or something like that in the end of the part. So now we'll talk about the associated benefits of using a steady rest. Increased rigidity for quicker metal removal. We have improved part tolerances, improved part finish, increased tool life, improved operator safety. That is especially true when we were looking at those parts that were requiring the secondary operation. So now we want to get in and talk about what types of steady rests are available. First of all, we'll start with the SLU Series steady rest. Those are multi-purpose for standard applications. They are available in both manual and automatic lubrication models. And we also have the side cylinder B models available for additional clearance. Here's a chart that shows our common stock sizes of the steady rest in the SLU series. Notice that the smallest size goes down to about 2.5 inches, and the largest size that we keep as a standard up to just over 18. There's a picture of what a standard SLU or X series might look like. And here's this picture of the side cylinder B model that we talked about. Now, if you notice in this picture here, the cylinder is mounted on the end of the steady rest. However, in the B model, we take that off of the end and we mount it here on the side. And then there's some additional linkage that goes through the body to work the middle arm and the outside arms of the steady rest. That might be necessary. You can see even in this picture, if the steady rest cylinder was sticking out of the end, we could perhaps have some interference with some of the front guarding, maybe even the front door of the machine. So the next model we have is the SOR Premium steady rest. Now, the Premium steady rest has the same mounting pattern and capacity as the SLU series. It has a fully sealed body, coolant wash through the coolant guards at the 3 rollers. It also has hardened arms for greater wear resistance and durability. And here's a picture of what a standard SR steady rest might look like, along with the different capacity sizes that we offer that in. Notice that we start in the 2 series. The 1 is a little too small to incorporate some of those features that we have added, like the coolant wash especially. Another picture of one. The coolant port, by the way, that provides the coolant to these coolant guards is in the back of the rest and ported through. This is a picture showing one of the coolant guards, and you can see the holes there. That's where the coolant would come out, the coolant flush. That coolant flush is very valuable for certain applications that have a lot of chips. We can keep those chips, flush them away so they don't go in between the workpiece and the roller of the steady rest. Moving on, now we go into the K model steady rest. The K model steady rest is a compact design that allows for larger clamping diameter and smaller machine envelopes. It also has the coolant wash through the coolant guards at the 3 rollers. And here you can see we start at the K2 series. Notice that even in the 2 series, we're getting up to 7-inch capacity in the K compact model, whereas the K6.1 is getting up over 20 inches of capacity. Again, that's a standard off-the-shelf steady rest. Here's another picture of one. So then moving on from the K-rest, we get into the KLU series. The KLU series is a narrow arm steady rest that's for use in clamping in grooves or short clamping diameters, typically camshafts or crankshafts. It also has the coolant wash through the coolant guards at the rollers. Here's a picture of them. Now, notice you can see that the first 3 series or 3 steady rest options have the same capacity. What's changing is the arm width. Notice that in the model number, the 215, so it's a 2 series, and the 15 reflects the arm width. So we have a 15 and an 18 and a 22 millimeter arm width, all in the same series. The reason for that is we want to maximize the arm width in the groove or clamping area that we have. Obviously, the wider the arm, the more rigid it is. So we want to try to keep as rigid of a steady rest in there as we can. Here's a picture of a typical KLU application. Again, clamping on a crankshaft. Another one, you can see that thin area that we have to locate in. So moving on, we get into our RX steady rest models. The RX steady rest is ultra compact in design. It allows for larger clamping diameter and even smaller machine envelopes. It also has the coolant wash through the coolant guards at the 3 rollers. And it is a premium style, so it includes the sealed body construction. Notice in the RX, we start at the 3 size, and it has the capacity of up over 10 inches. And then we get into our largest model, the RX 6.1, and it goes up to 27 inches. Now, one of the ways that we're able to accommodate that inside machine enclosures is, you notice we talked about the cylinder on the end of the other steady rests. In this case, the cylinder is integral to the steady rest. It's actually built into the middle arm, and that's one of the ways that we're able to accommodate such a large capacity. A couple pictures of that. See the arms open up, 27 inches. So then we get into the last type of steady rest we're going to discuss, and that's our manual steady rest. Manual steady rests are a C-style design. They have very large clamping ranges. They're custom designed to fit machine and application. Here's a picture of one. Now you can see we talked about it's a C-style. What does that mean? Well, it's shaped similar to an automatic rest like this, a C. And the reason why we do that, some models out there are what they call a full wraparound, and we prefer the C design because what that does is it allows additional clearance up here for the upper cross slide and tools to get by as you're machining, whereas like a full wraparound style, you may have more interference there. And this is a good picture of another manual rest from the backside, and you can see how we've actually designed the steady rest to fit right inside the machine door profile to make sure that we've maximized as much capacity out of the manual rest as we can. So we talk about what are the pros. Well, it's a lower cost. It's an easier installation. It's designed to maximize the machine capacity. There's no special interface required for most applications. The cons are it's not self-centering. Each roller is manually adjusted by the operator. It becomes very operator dependent, so you're going to get less predictable results. And we do not have an ability to automatically lubricate the rollers. They do have grease fitting zerks at each roller, but we can't automate that. So with all the steady rest style or types that we just discussed, there are 2 different bearing styles available for each of those. Of course, we have the cylindrical or straight bearing that's used for most applications. It can be used for standard support on straight diameters, whether that be fixed or traveling applications. And then we offer the spherical bearing. The spherical bearing, of course, is for locating on a taper or a radius, and usually can accommodate about a 5 degrees per side angle. They are also good for either fixed or traveling applications. So here's an accessory for the SLU-X series. You noticed all the other ones we discussed had cooling guard options, not available in the SLU series. So one accessory that we have to help with chip control is our spring-loaded guard that has a brass wiper. That brass remains in contact with the workpiece for better chip control. So now we want to talk about some of the items that's necessary to mount a steady rest onto a machine tool. Well, of course, we have the steady rest itself, and then the mounting bracket, perhaps a base, whether that be manual or programmable, hydraulic valve packages, lubrication packages, way covers, whether they be manual or a telescoping design, hose tracks, the interface to the machine tool, the M codes, usually OEM provided, and of course the professional installation. So here's some mounting options. Notice on the far left, the most common, of course, is mounting directly to the tailstock ways of the machine. We can also mount to the lower turret of like a 4-axis lathe. You can see the turret here. We're mounting, in this case, directly to the face. And we can also mount on a machining table. Usually when we put it in a machining center, it bolts directly to the T-slot table, and it's used in conjunction with a rotary table that you can kind of see over here to the far right side of the picture. So let's start talking about steady rest bases and brackets. Of course, the base can be designed to fit either linear or box ways. They can be either manually or programmably positioned. They have the ability to have an automatic or manual toe pin, and there are in-position switches available. We'll talk a little bit more about that in a minute. So on the brackets, our designs are for base or way mounting. We have a steel weldment construction for both strength and rigidity. Both sides are machined for either right, left, or tandem mounting. Here's a picture of a manual bracket on a machine. Notice in this area, you can see these are the bolts that would be used to tighten it down to the box ways in this machine. This is what they call a manual advanced latch pin. Let's see if we zoom in on that a little bit. This is a thumb screw here. So this pin can be advanced forward and engaged a U-block that would be mounted onto the upper cross slide. And that's how you would drag this steady rest up and down the tailstock ways on the machine. Once you get it into position, then you would manually retract this pin and go ahead and tighten up the clamp bolts. So then we also have a programmable base, could even be a programmable bracket. This base is automatically clamped and has an automatic pin. Take a look at that up a little bit closer. We talked about the U-block in the previous picture. This is what it would look like mounted to the upper cross slide. And you can see this pin here is cylinder advanced and cylinder retracted. So as the pin is advanced, the base is automatically unclamped. The upper cross slide drags it to the new position. And then at that point in time, the pin would be retracted and then the base would clamp back up. And then most importantly, the machine control has to then remember that location of where we dropped it off so it knows where to go back to get it. So we also offer valve packages. That's the hydraulic solenoid valves and the pressure reducing valves. Also includes stainless steel braided hoses. And we usually put quick disconnect fittings on all of our installations. And that's for the aid of getting the steady rest in and out of the machine quickly. The lubrication units we offer are fully programmable units, and that's to provide the proper lubrication for the rollers and internal wear surfaces of the steady rest. And it also includes both low level and pressure loss alarms. Other accessories that we provide for some installations include telescoping covers. Telescoping cover is to provide protection for ball screws and perhaps linear guideways on the machine. And then hose tracks are available also for some applications. We use these to protect the hydraulic and electrical lines, used mainly for automatic base applications. Here's some tips and tricks for getting the most from your steady rest. First of all, always ensure that the steady rest is properly aligned to the machine spindle center line. Now, our service techs will do that on site. That's one of the final things that they'll do during an installation. And hopefully you have an operator or a maintenance person around that's available to be trained before he leaves the building. We always want to make sure we use the proper type of lubrication, which is ISO 46 at the correct intervals. That's for both the steady rest and the rollers. We always want to use the lowest hydraulic pressure that gives you desirable results. The reason for that is there's no reason to put additional load onto the roller bearings themselves than what's needed, because that will shorten their life. We always want to turn the part prior to engaging the steady rest. We want to turn the steady rest band in an area where we can get a good round diameter that's free of chatter. You might need to start a little closer to the headstock or to the tailstock and then work your way to the center of the part. You do not want to engage the steady rest on a part that's rotating at higher speeds, as this can develop flat spots on the rollers. And also, you always want to ensure that the steady rest rollers and chip guards are in good working condition. Let's take a look at just a couple applications. Here's what we call a double steady rest application. Notice these are SR5s. You can see the coolant guards up here. Each steady rest is mounted onto its separate bracket and a separate base. That's the reason why we would call it a double. A tandem, such as what you see in the picture here, is a single bracket with the steady rest mounted on both sides of that bracket in tandem. You can tell by the number of lines here that each of these steady rests can be activated independently of each other. And then this is where the hydraulic or where the lubrication and the air lines are teed together. Here's another tandem steady rest application. And this is a really good picture to talk a little bit more about what we had mentioned earlier. And that's about turning a diameter that's round and true prior to engaging the rest. You can notice here that we've got quite a bit of chatter in this area. So we don't want to engage the rest on that yet, because if I do, it's extremely likely that as I machine anywhere else on this bar, I will see that same amount of chatter or marks in the part. So a much smarter thing to do is to move away from the center of the part, closer to the headstock or the tailstock, and machine over here where I can get a good round diameter, clamp on it with the steady rest, and then move back closer to the center to do additional machining. Here is a typical turret mounted steady rest application. We showed a picture earlier. This one's a little different because it includes the rotary coupling here on the front. We add the rotary coupling to the front of the steady rest. What that does allows the lines to come in it so that the turret and the steady rest can index. And that allows you the use of tools in the other open pockets of that turret. Here is a multiple steady rest application. Actually, what we have here is 3 sets of tandems. So you can notice both of these are mounted to one bracket with spacers in between. The same with these other 2 tandem setups. This is a good representation too. We talked about adding quick disconnect fittings in our installations. And again, we do that to make it easier to pull steady rest in and out of the machine for when they are not needed. Just another tandem steady rest application here. K3 steady rest. Again, K models also have that coolant guard on them. This is an interesting picture. It again shows the reasons why we machine both sides of our brackets. In this case, if the steady rest was mounted onto the other side, and that was the only option we have, it's very likely that this very large diameter of this part would be interfering with the bracket. So we needed to have the ability to put the rest on the left side. And there's just another SR5 steady rest application, base mounted. Double steady rest application. You can see in this area that we have yet to put in the telescoping weight covers that are going to be needed. This is a ball screw down in this area, so that needs to be protected. And that would be the final part of this installation. So what do we need to know to incorporate a steady rest into a machine tool? Well, we need to know the max diameter, the min diameter to be clamped to make sure we have the right range. The length of the parts are very important. That's going to help us determine if we may require more than one steady rest. Is it going to be a fixed or traveling steady rest application? How is it going to be mounted in a machine? If it's tailstock mounted, is it going to have manual or automatic positioning? If turret mounted, do we need to worry about index capability? Is the steady rest going to support a straight and or tapered part? And the reason why that's important, of course, is so we know what bearings to put on the steady rest before we ship it. And it is possible to switch back and forth too. So if we have straight parts, you may want to use a cylindrical, and then when we go to a tapered part, that would be a good time to switch over to the spherical bearings. It's very easy to do. There could either be manually greased or automatic oil lubrication. We need to make sure that that steady rest interface is available from the OEM, extremely important. And we need to make sure that that's installed and operational prior to us getting on site for installation. And then finally, do you have any special delivery requirements? So here's my contact information in case of any questions or you need to get a hold of me on anything. You can see my phone number there, 513-388-5002. And then of course my email address is epeter@lns-northamerica.com. So at this time, that kind of wraps up my presentation. So what I'd like to do now is to reach out to Brad Hasty and just to see if there's been any questions that have been posted or anything that we can answer before we finish up with this webinar.
Hi, Ed. Yes, we have a couple of questions that came up. One of them was interface related. In the presentation, you mentioned the OEM steady rest interface, and the customer is asking whether the full-blown interface from the OEM is required or will M codes be sufficient?
We always prefer the full-blown interface from the OEM. The reason why is that generally consists of interlocks into the machine control. There's a lot of advantages too, where they can add like a manual push button or touch buttons on the screen as part of the interface. It is possible, of course, for us to work off with just M codes, but that way you really would, the only way you can execute those is in the program itself. So we definitely prefer the OEM supplied interface.
Okay, thanks, Ed. And one other question is, any advice when using high pressure coolant, 140 bar, sealing specific models, that sort of thing? Is that possible with our through the arm coolant steady rests?
Yes, the maximum pressure that we can put through the arm of a steady rest is 300 PSI. We'd like to stay even slightly under that. And the reason why is because that coolant, as we had mentioned, comes in through a port on the rear side of the steady rest. And as it's ported through, there's a number of seals for all the different moving parts, and anything over about 300 PSI can be damaging to those seals. So let's try to keep it under 300 and we should be safe.
Okay, we did have a couple of questions that were machine tool brand and application specific, and those customers will be contacting you after the presentation.
Sounds great. I appreciate that, Brad. And with that, that kind of concludes our webinar today. Once again, I'd like to thank everybody for joining and attending it. I hope you found this webinar to be informative. And of course, we look forward to working with you on any future projects.